in this lecture, we are going to study another important hook, which is the useCallback. However, it is so important to understand performance optimization before we proceed with useCallback. And hence that is clear to you, we can now discuss what a useCallback is, why and when you should use it. And here I have already built a simple counter application. So quickly, let me walk you through it. Let's head on to the app component. And over here, we have rendered a component called main component. And here is it. So right within the main component, we have two different components which is reused with different properties to show different informations. And the first is the counter component. This counter component over here is responsible to display the current number of teachers. The button component is responsible to increment the teacher. And then here we reused the counter component to show the number of students. And then also we reused the button component to increment students. And all of this function over here is defined at the top. Here we have the increment teachers function, the increment student, and then we have the necessary state variables at the top. So right within this function, we are incrementing teachers by 5. And here we are incrementing students by 10. Alright, so all of this will happen when the button is clicked. So come back here. When you observe this component, you will realize that we are passing text as props and as well the current state of the teacher. And right within the button component, we are taking the handle click as props and then we pass in the increment teachers function as its value. And this function is defined at the top. Of course, I've shown you already. And same thing here. We are taking in test and count as props and then we pass in the value of the current student. And right within this button, we pass in the handle click as props and we are taking in the increment student as its value, which is the props value. Quickly head on to the button component. So right within the button component, we destructured handle click and children. And here we implemented a button, and on click of this button, we are taking in this props, which is the handle click that has got the value of the increment teacher and the increment student function. And over here, we are passing in the children as an inner HTML. So this is going to show the text in between the button. Let me show you quickly in the main component. So the inner HTML over here, this guy, increment student and increment teacher. This will be displayed because of the props.children. Of course, you should know that by now. And quickly, let's move on to the counter component. Right within the counter component, we destructured test and count. And over here, we are taking in test and count. The count will display the current value of the teachers and the students. To wrap it up, we created a new directory called useCallback practice. And here is it. So right within this directory, we created all of these components. And then we rendered the main component in the app.js. And for sure, the button component and the count component is nested within the main component. And at the top, we imported them. It's as simple as that. Haven't understood the application? Let's quickly proceed with the business of the day. Close it down. So the purpose of this example is to focus on performance optimization. And to measure the performance, we have some log statement over here. Let me show you. Can you see? So this will help show the component that is being rendered. And over here also, we have some log statement. So right within the terminal, we have to run the application. Perfect. This is exactly what we are expecting. So when I click on increment teachers, teachers will be incremented by 5. Do you see? And when I click on increment student, student will be incremented by 10. Everything seems to be working perfectly fine, but let's quickly check out the console and see what happens. Alright, so for a start, we just have to clear the console again so that it appears clear enough. Now, I want to hit on the increment teachers button. When I click on the increment teachers, you are going to see rendering teachers, rendering button increment teachers. And over here, you are going to see rendering students and rendering button increment students. When I click on the increment student, you are going to see exactly the same log statement. Rendering teachers, rendering button increment teachers, rendering students, and rendering button increment students. So, here exactly is where the problem lies. Because if we click on the increment teachers, there is no need to re-render the increment student component. But in this case, when we increment teachers, the student components will be re-rendered. And as well, when we increment students, the teachers component will be re-rendered. And this will cause some performance issues in your application. So just imagine we have over 100 components over here. And by updating a single component, the rest of the 99 components will be re-rendered. Friends, that won't be nice at all, because you will begin to experience some performance issue. And therefore, to optimize performance, we have to precisely render only the component that needs to be re-rendered when its state or props changes. And that will be done with React.memo. React.memo is a fantastic tool for memoizing functional components. And when applied correctly, it prevents a functional component not to re-render if the props or state did not change. Sounds good? Beautiful. Alright, so you can think of memoization as a way of couching a value, such that it does not need to be recalculated when the state or props did not change. So let's quickly optimize this application with React.memo. VS Code, and quickly let's head on to the main component. Alright, so to optimize the application, what we are going to do is quite simple. So what I'm going to do right now is to highlight this guy, export default, and then cut. Come here, paste it, and then we are going to do react.memo. And now we have to pass in the component. It's as simple as that. So what I'm going to do right now is to highlight and copy. Let's go to the button component. Come here, paste. We have to change the component to button component. And over here, let's remove the export default. Do the same in the counter component. Remove the export default. Come here, paste. So here we have to pass in the component of concern, which is the counter component. It's as simple as that. Save, and let's check out the browser. Refresh. On the first render, you will see all the components right here on the console. Rendering teachers, rendering button increment teachers, rendering students, and then rendering button increment student. Let's clear the console. So now let's give it a try by clicking the increment teacher. Can you see? Now we have rendering teachers, rendering button increment teachers, and then rendering button increment students. For now, we are able to optimize the application just a little bit. Okay, because here we still have the rendering button increment student right on the console, which is not very good. So when we hit on increment student, you are going to see rendering button increment teachers, rendering student, and then rendering button increment student. So the intention of this lecture is to prevent unnecessary render. Okay, so because when you click on the student button, the teachers related component should not be re-rendered. Okay, And as well, when you click on the teachers, the student-related component should not be re-rendered. And now this will throw another challenge, because we are not changing the state of the student component, but here it is being re-rendered. Okay, let me quickly show you again. When I click on increment teachers, you see that rendering button increment student. We are not changing the state of the student component, so we do not want it to be re-rendered. But here on the console, you can see that the student component button is being re-rendered. So when you clear the console and do the same to increment student, you will see that the teacher related component, which is the button component of the teacher, is being re-rendered as well. So this is referred to as unnecessary renders. Let me quickly explain to you what happens under the hood. Head on to the main component. So over here, we have the counter component and it accepts teacher as props. The button component accepts the increment teacher as its props value, which is the function that is defined at the top. Here is it. So this simply means that when the state of the teacher gets updated, the counter component of the teacher and the button component of the teacher will be re-rendered. But the problem now is that even the student button is being re-rendered, though the counter component for the student do not re-render. Okay, so this happens simply because when you call the increment teacher function, a new increment student function is created each time the parent component re-renders. And for sure, when working with function, we must put reference equality into consideration. So even if these two functions behave exactly the same, that does not mean that they are equal to each other. Therefore, the function before the re-render is different from the function after re-render. So simply because we pass the function as props, React.memo will quickly realize that the props has changed, and then it won't be able to avoid the re-render. Sounds tricky, right? Let me break it down. When you increment teachers, a new increment student function will be created, which will cause the increment student button to re-render. And when you increment students, a new increment teacher function will be created, which also will cause the increment teacher function to re-render. And now the question is, how do we inform React not to create a new increment student function when we update the teachers? Alright, so here exactly is where useCallback comes in. So what is the useCallback hooks? The useCallback returns a memoized version of the callback function that only changes if one of the dependencies has changed. So in simplicity, the useCallback hook is used when you have a component in which a child is rendering repeatedly without the need for it. Alright, so to implement the useCallback, several conditions must be satisfied. Condition 1 is that we must have a callback function. The second condition is that we must optimize the child component with React.memo. Let me show you. Here we optimized the child component, and here we also optimized the child component. The third condition is that we must check the reference equality. For the reference equality, we have to check if the functions are equal. So if the above condition is satisfied, we can then proceed to further optimize our application with the useCallback hook. Alright, so to implement the useCallback hook, several steps are involved. Don't worry, the steps are indeed very simple. Scroll to the top. First, we have to import the useCallback. And after that, step number 2 is to invoke the useCallback. And the useCallback is a function that takes in a callback function as its first argument. So what I'm going to do right now is to copy this function like this, highlight, cut, come here and paste. And after that, we have to assign it to a variable like this. Alright, beautiful. So the second argument of the useCallback is a dependency array. So what I'm going to do now is to specify a comma and then take in the dependency array. And this callback over here depends on the teacher's variable to get fire up. Come here, highlight and copy, paste it right within the dependency. So this function will get triggered only when the state of the teachers changes. It's as simple as that. So let's replicate the same thing for the student. Use callback. It accepts a callback function as its first argument. Copy this, highlight and cut, come here, paste it. And then over here we have to assign it to a variable like this. The second argument is a dependency array. This will get fire up when the state of the student changes. So we just have to specify student as a dependency array. So it simply means that it depends on the state of the student to get fire up. If the student state did not change, the function won't get called. It's as simple as that. So we have to assign it like this. Having done this, let's quickly check it out on the browser. I'm going to refresh. Beautiful. So for the very first time when the application loads, the whole of the component will be rendered. Let's quickly refresh the console. So when you click on the increment teachers, on the console, you will realize that only the teachers related component is what is being re-rendered. Okay, so you are not going to get unnecessary re-renders like the student component anymore. And as well, when you increment the student, let's clear off the console and then increment student. You will realize that only the student related component is what is being re-rendered on the screen. And the proof is right on the console. So with this, we can say that the application is fully optimized. Can you see? So we no longer have some useless re-renders. This is extremely awesome and I love it. Friends, this is all for now and see you in the next lecture. Stay focused and always take care.